Hello, everyone, and welcome to this Explainer. I am Ahmed Matawi. I'm a freelance consultant and a space tech ambassador, specializing in AI strategy for high-security, regulated sectors like defense. My core focus is really bridging the gap between technical complexity and executive strategy. And look, if you're a leader trying to navigate this transition into a carbon-free economy, I actually offer an exclusive Udemy course right now called Generative AI for Leaders in Management. But let's jump right into the problem we're solving today. Right now, global organizations are under, overwhelming pressure. They're being pushed to transition rapidly into a highly regulated, carbon-free economy, and the sheer scale of the challenge is massive. So let's dive into the planetary intelligence that's helping us tackle this head-on. Imagine a massive data task. What previously took 4 full-time consultants over a month and a half to pull off can now be done in mere minutes. Literally minutes. That is the staggering reality of using generative AI for automated carbon footprinting. Proprietary AI solutions can crunch through millions of rows of emissions data almost instantly, matching emission factors with just incredible precision. This doesn't just save time, it completely shifts how sustainability teams operate, getting them away from endless manual data compilation and toward actual strategic climate action. Section 1. The Net Zero Data Challenge. Okay, so the absolute core of this data challenge lies in Scope 3 emissions. For those keeping track, these are the indirect greenhouse gas emissions generated across a company's entire value chain. So we're talking about everything occurring outside of their direct operations and the energy they purchase. Think about the logistics, the raw materials, even the end-of-life treatment of the products they sell. The kicker here. This is, without a doubt, the hardest data for corporations to track accurately. Historically, we've had to just rely on industry averages to guess this stuff, which obviously leaves massive gaps in accuracy. And here's the thing, tracking this accurately, it's no longer optional. Global regulatory pressures like the EU's Corporate Sustainability Reporting Directive and the Carbon Border Adjustment Mechanism, or CBAM, are forcing companies to report highly verifiable climate data or face some pretty severe consequences. Right now, Egyptian export industries, for example, face rising costs and massive competitiveness risks under CBAM. Specifically, exporters are looking at punitive cross-border tariffs of up to €95 per ton if their carbon accounting isn't airtight. Precise carbon accounting is really a matter of corporate survival and maintaining market access. It's definitely not just a public relations exercise anymore. Section 2, AI's double-edged climate sword. Now, you might be thinking, AI is the obvious solution here, right? Well, it is, but it comes with a pretty complex tension. On one hand, AI infrastructure demands a staggering environmental toll. We're talking massive data center energy use, with half of that energy dedicated literally just to cooling the servers. A mid-sized data center can gulp down up to 300,000 gallons of water every single day. But on the flip side, AI offers incredible systemic benefits. It can optimize our power grids and accommodate huge amounts of new industrial demand without breaking a sweat. In the US grid alone, AI could intelligently shift loads to handle up to 98 gigawatts of new industrial demand. It's this really crazy balancing act, intense resource consumption on one side versus this powerful, large-scale decarbonization capability on the other. Section 3, Space Tech and Earth Observation. So how do we bridge this gap? This brings us to MRV, Measurement, Reporting, and Verification. This framework is the gold standard for climate accountability, absolutely crucial for stopping corporate greenwashing in its tracks. And this is exactly what we're tackling through the 8 in Space Tech initiative. We are building Eco-Urban Space, which is a sovereign MRV platform powered by satellite data and AI analytics. By integrating multi-sensor data from satellites like Sentinel and Landsat, we provide tamper-proof compliance dashboards. And the real-world impact? This directly reduces carbon certificate costs for exporters by up to 31%. It turns theoretical climate models into grounded, actionable, and very real financial savings. To give you a visual of what this planetary intelligence looks like, satellites from orbit can reveal things like the sprawling dendritic patterns of water networks, like what we see with Lake Nasser in Egypt. This goes to show that modern carbon tracking isn't just about reading static spreadsheets in a back office anymore. No, it is literal, planetary-scale remote sensing. We are observing the macro health of entire ecosystems in real time. And when you contrast that beautiful, macro, natural view of Lake Nasser with the highly structured micro view of East Awainat's pivot irrigation systems, you really start to see the true power of this technology. AI processes the space tech data to monitor both flowing natural ecosystems and human-engineered agriculture at basically any scale. It beautifully bridges the gap between these massive natural phenomena and highly targeted industrial operations. Unsurprisingly, top tech innovators are already all over this, applying space tech and AI to deliver audit-ready carbon intelligence. You've got companies like Planet using hyperspectral detection for 3-meter resolution forest monitoring. Climatic is out there automating Scope 3 emission factor mapping. Boomatra is utilizing soil carbon remote sensing for Vera-certified credits. And Treefera? They're fusing drone and satellite data for just incredible supply chain transparency. These innovators are taking raw space data and turning it into highly actionable, quantifiable outcomes. Section 4. Urban Monitoring in Egypt. Let's bring this closer to home and look at a specific case. By processing Sentinel-2 satellite imagery, machine learning algorithms can track staggering urban infrastructure growth. Using a super effective random forest model, we're talking 98.8% accuracy here, the data revealed that the urban area of Egypt's new administrative capital increased from 55.7 to 94 square kilometers in just 4 short years. Transportation networks basically doubled. But, this is about way more than just monitoring concrete. It's about profound social impact. By ensuring continued EU market access, our platform actively protects jobs in energy-intensive sectors across the country. Furthermore, we use this exact satellite data to monitor and mitigate urban heat island effects, which can actually lower cooling energy demand by 15 to 20%. We're fostering cleaner urban environments and protecting public health, all while keeping industries resilient. Of course, rapid development doesn't happen in a vacuum. It has environmental consequences. Data captured by the Sentinel-5P satellite shows a 75% increase in nitrogen dioxide levels and an 11% increase in carbon monoxide levels in the new administrative capital during that same growth period. Noticeably, though, there's a temporary dip in pollutants that occurred during the 2020 COVID-19 lockdown. It's a really powerful reminder, isn't it? Human activity directly correlates with atmospheric chemistry, and space tech is now precise enough to measure that exact impact from orbit. Section 5. Predicting carbon credit markets. Now let's talk money, because there is a fundamental difference between market types in the carbon space. First, you have compliance markets. These are strict, legally regulated mandatory schemes, like the EU emissions trading system. Then, on the other side, you have voluntary markets. These are driven by corporate social responsibility offsets and are certified by independent bodies, like Vera or the Gold Standard. So, while the compliance markets offer stable but super strict regulation, the voluntary landscape is, it's highly variable and honestly a bit unpredictable. Which brings us to what I call a multi-million-dollar dilemma for any executive. How can corporations actually predict the volatile prices and shifting regulations of the carbon credit market? Think about the immense financial risk involved when an entire industry faces punitive tariffs or wildly fluctuating offset values. How exactly can technology step in to tame the chaos of carbon trading? The answer, as you might have guessed, lies in advanced machine learning. AI-driven forecasting using long short-term memory or LSTM networks acts basically as a high-tech financial compass. It analyzes massive, complex data sets encompassing climate variables, financial trends, and global policy shifts. By doing this, it optimizes carbon credit investments and completely automates ESG compliance. It guides corporate investments based on predictive emission statistics, ensuring companies buy credits at the right time and the right price. This protects their bottom line while keeping them perfectly aligned with regulatory demands. Section 6. The future of decarbonization. As we wrap up, I want to leave you with this thought. We are currently undergoing a true computational metamorphosis of carbon accounting, shifting from static linear equations to high-dimensional agenic optimization. By bridging space innovation with industrial resilience, we are actively advancing climate accountability across Egypt, Africa, and the entire globe. Join us as we build a sustainable, carbon-neutral future. But it does leave us with one final, provocative question to ponder. Will this massive technological metamorphosis, with all of its immense computational power and resource-heavy data center infrastructure, ultimately save the environment it currently burdens? Thank you so much for joining me on this explainer.